Okay, in today's lesson, we're going to be doing ELR 11.2. It's about finding surface area of a prism and a cylinder. All right, so let's talk about what a prism is. It's a polyhedron with two congruent parallel faces called bases, and the other faces are called lateral faces. So it has the same base at the top and the bottom. So this picture here is a triangular prism, and you name it by the base. So this is a triangular prism. If it was at a different base, a pentagon, it'd be a pentagonal prism. And all the ones that are meeting and joining it, going around this part here, are called lateral faces. We could have prisms that are going straight up. Those are called right prisms, like the ones on the left. And we could also have prisms that are oblique, that are on a slant, but they still have the same height there. All right, so let's talk about the difference between lateral area versus surface area. Lateral area is the area that's going around the object, that forms that big length that makes that hollow piece inside. Surface area is everything on the shape, the bases plus the lateral faces. So lateral area is just your lateral faces, and surface area is everything, the whole shape. Okay, so here is the specific lateral area and surface area for a prism. So lateral area is P times H. P is the perimeter of the base, so you have to locate what are your bases. And then you're going to times that perimeter times the height of the prism. That's your lateral area. The surface area of a prism is the sum of the lateral area from above, pH, plus we have to find the area of the bases, and you have two bases, so you're going to double that. That's going to give me a total surface area for a prism. So there is a piece of paper that I had actually to print out. This is where I would put both of those two things there, lateral and surface area, on that piece of paper. So let's take a look at the prism here. It's a triangular prism. We're going to find the surface area first. All right, so let's do the formula. P times H. Well, what is the perimeter? So we have a triangle here, 3, 4. We need to figure out this third side. So it's a right triangle. We know to find a side from a right triangle, we got to do Pythagorean theorem. So I'm going to do the Pythagorean theorem here, plug in the two legs, and I get this to be, oops, that's not good. I pressed this by accident, my bad, sorry. We get it to be c squared equals 25, so square root of 25 is 5. So this third side on this triangle is 5. So let's do the perimeter. So we're doing 3 plus 4 plus 5, and we're going to multiply it by the height of the prism, which is 6, plus 2 times, well, what is the area formula for a triangle? The area formula for a triangle is base times height divided in half. So the base and the height is 3 and 4. Divided in half, 12 divided in half is 6. So I'm going to do 2 times 6, because I got 2 of them. We work it out. What is this? 7 plus 5, 12 times 6 plus 12. We got the total area to be 84 centimeters squared. All right, let's talk about cylinder. Cylinder, lateral area, and surface area. So the lateral area there is the height of that cylinder going around. 2 times pi times r, that's the circumference of the circle. I'm going to multiply it by the height. So 2 pi rh is the lateral area. Surface area is going to have that 2 pi rh plus 2 pi r squared, because we're finding the area of the bases. So these are both formulas for lateral area for a cylinder. And again, we could have cylinders that are right cylinders or oblique cylinders. They still have the same height, even if they are on a slant like oblique. And again, this should be going on that piece of paper for your lateral and surface area paper for all those shapes. Let's take a look at this example. You have a cylinder that has a height of 9. So I'm going to just make a quick cylinder here. It has a height of 9 and a radius of 10. What is the surface area? And leave it in terms of pi. So I'm going to write down the formula. Surface area 2 pi r h plus 2 pi r squared. I'm going to plug in the r and the h, and I want to leave it in terms of pi, so I'm not going to put pi in the calculator. So I work this out. This is 180 doubled, so this is 180 pi plus this is 200 pi. We add that together and we get it to be 380 pi centimeters squared. So I left it in terms of pi. That's the total surface area there. All right, last question. This is something that you use if you're painting a wall in the house. It's saying how many revolutions did the stencil make? If I want to find the area, oh, I forgot this got stuff, didn't go in. You want to paint an area. I want to paint an area of 60 pi inches squared. So here are the dimensions of this lovely cylinder looking thing. We got this height of 6. The 2.5 here is the radius. And we want to know how many revolutions to paint an area of 60 pi inches squared. So I am not concerned about total surface area. I'm just concerned about this part here, which is the lateral area. And what was the lateral area for a cylinder? It was 2 pi RH. So let's plug in our stuff. 2 times pi times r times h. When I work it out, I get it to be 30 pi. So how many revolutions can I make to paint an area of 60 pi? That would be just 2 revolutions, right? Because one time it goes around is 30 pi, and then another time around would make it 60 pi. So 2 revolutions to paint that possible area piece.